All right, let's go on ahead to, to lesson 5.3. We're going to look at adjusting estimated divisors. Here is your I can statement. I can recognize and adjust the divisor if it is too small or too big. Go ahead and get that written down, pausing if you need to. All right, so we have to be thinking to ourselves, is our estimated divisor too large, too small, or just right? Does that sound familiar?
This porridge is too hot. This porridge is too cold. This porridge is just right.
All right, good old Goldilocks. So let me show you what I mean. In this problem, okay, remember we've got our dividend, our divisor, we're looking for the quotient. So we're working on the divisor today. If I'm going to round that, 85 would be rounded up to 90. So to do this problem, I'm asking myself, okay, how many 90s? We don't have any in 5 or 51. How many would be in 518? Well, I know that 5 times 9 is 45, so that'd be 450. Now I need to multiply my exact number, and then when I do that, 5 times 85 is 425. So I'm going to subtract. Now look what happens. When I subtract, okay, so we multiplied, we subtracted, now I'm going to check. That 93 is larger than the 85. So that's a problem. Remember I told you we have to check, and that must be lower. And if it's not lower, that means this number is too small and we've got to go with something one higher. Okay? All right, so how do I know that the first estimated number is not right? Because when I check, it's too large. All right, so what do I need to do? Erase the numbers I have and increase the estimated number by 1 and then multiply again. All right, so 5 was too small, so I'm going to increase it by 1 and use 6. So I'm going to do 6 times 85, which is 510. So now when I subtract, I'm good to go. That number is smaller. I've checked it. Now I can bring down. I've got 85, and I know that 1 times 85 is 85, and I'm done. Okay? Now, what about the other method? Expanded notation. Same idea. We're going to first round the divisor. So 85 rounds to 90. Now, I know that 5 times 9 is 45. So this is going to give me 4,250 when I multiply by the exact number. Okay? Now, that's okay in this method. It doesn't matter because I can just use another friendly number here. I know that, I'm sorry, let me back up. Do I need to change the estimated number when using? Like I said, no, because I can just keep building the quotient and add all the numbers together at the end. So let me show you what I mean. 10 times 85 is 850, so I can subtract, and I've got 85, and I know that I'm going to have just one of those left. So the nice thing about the expanded notation method is you can just keep adding numbers on here, and you still get the answer at the end of 61. Now we could have started with 60 here. We could have increased, but like I said, in this method, you don't have to. All right, so what kind of divisor is most likely to give you an estimate that's wrong? All right, so we're going to look at a few problems here and see if we can answer that question. So let's look at the first one. 41. How many 41s would be in 258? So I'm thinking, okay, that rounds down to 40. And I know that 6 times 40 is 240. So when I do 6 times 41, I get 246. Now when I subtract, I'm going to get 12, and I'm going to be okay there because 12 is less than 41. Let's look at the next one. 34 rounds down to 30. So I'm thinking, okay, I know that 5 times 30 is 150. So when I do 5 times 34, I get 170. All right, that is too much. 5 is not going to work. I would have to go back and change that. I've got to get a number that's lower, so I'd have to change that down to a 4. Let's look at the next one. By the way, you notice I'm not doing all the whole problem. I'm just looking at this, the very first step here. I should have clarified that from the beginning. Okay, let's look at this one. When we round off our divisor, we round it up to 30. So I'm thinking, okay, how many 30s are in 92? And I know that 3 times 30 is 90. So 3 times 29 gives me 87. And when I subtract that, I'm going to get a number that's less than 29. So I'm going to be okay, and I can go ahead and finish that problem. Let's look at the next one. 16 is going to round up to 20. How many 20s are in 146? Well, I know that 7 times 20 is 140. So when I subtract, 7 times 16 is 112. I'm going to get a 4 there, and I'm going to get a 3. I'm going to get 34. 34 is more than 16. So I'm going to need to increase this number to 8 because this is not close enough to 146. So notice that in problem number 8, we had a divisor that ends with a 6. This is one that did not work. Over here, this one did not work. And notice that this one ends in a 4. So what kind of divisor is most likely to lead to an estimated number that's wrong? Well, guess what? It's going to be divisors with a 4, 5, or 6 in the ones place. Okay, a 4, 5, or 6 in the ones place. The digits that are hovering right around 5, those are the ones that are going to be iffy. We're not going to know for sure if our estimated number is going to work. So how do we adjust? Well, we're going to either have to subtract from the subtract one digit from the quotient if it is an overestimate estimate, or we're going to have to add one if we have underestimated. Okay. All right. So here's just one practice problem. I want you to give this a try. So remember to round this. Go ahead and get started. See if your estimate is okay. And if it's not, you'll have to make an adjustment. All right, we'll see you soon. Guess what? No guiding question for this lesson.